Hello and welcome to our lesson on solving quadratic-like equations, or sometimes they're called quadratic-type equations. So what we're going to be looking at are equations that have properties similar to quadratic equations, and so we can solve in similar ways, technically using a process called substitution. So first of all, what does it mean for an equation to be a quadratic-like equation? What does it mean to have properties like a quadratic? So a typical quadratic equation in standard form is going to look something like this, where you have an ax squared plus bx plus c equal to 0. Remember, that's our standard form. So I just picked a 1x squared plus 4x plus 3 equals 0. Well, everything below that quadratic is no longer a quadratic. However, each of those equations can be solved in the same way we would solve the one that I've highlighted. So in the same way that I would solve x squared plus 4x plus 3 equals 0, I could solve everything else. Okay? Now, how exactly would I solve that particular equation? Hopefully you're looking at this and recognizing that it's factorable. Sorry. It's factorable. If I factor into x plus 1 and x plus 3 equals 0, then I could easily see my solutions would be -1 and -3, right? No big deal. Well, that factoring process to solve to get those two solutions is part of the process we're going to use to solve everything below. Now, let's establish first why the rest of these are like the quadratic that is above. Okay? They have the same properties. So what is the same about every other equation below the quadratic that we're looking at? Well, notice the coefficients. Coefficient of 1, coefficient of 4, and actually the constant of 3. Coefficient of 1, coefficient of 4, constant of 3. 1, 4, and 3, and 1, and 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 4, and 3. Okay, coefficients and constant. There's three terms in each of these, and they all have the same coefficient. First coefficient, they all have the same middle coefficient, they all have the same constant. So they've all got 3 terms equal to 0. Third term is a constant in all of them, and the coefficients for the variables are the same in all of them. Okay, what else? There's a little bit more to it. So 3 terms equal to 0, constants the same, coefficients are the same. The other piece is there's a connection between the exponents on the variables. So here we have 2 and 1. Here's 4 and 2, 6 and 3, -2, -1, 1 and a half, 2/3 and a third, 2 and 1. What is the connection? Well, the two ways you can think about it. The middle exponent is half of the first one, so 2 divided by 2 divided in half, right, is going to give you 1 here, or 4 divided by 2 is going to give you 2 here, or 6 divided by 2 is going to give you the 3 that's here. Or if you wanted to work backwards, if you just double the middle exponent, okay, double the middle exponent, then 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, -1 times 2 is -2, a half times 2 is 1, a third times 2 is 2/3, and so on. Okay, so this is what it means for our equation to be quadratic-like. So if we were to rewrite it as a quadratic, it would have the same properties. Those 3 terms in order equal to 0, constants the same, coefficients are the same, and the first exponent is twice the exponent that we have in the middle. Okay, so that's the criteria. There have to be 3 terms set equal to 0. The third term should be a constant, and the exponent on the first variable is twice, it's double, the exponent on the second variable. Okay, so if we've established that we have a quadratic-like equation, we're going to actually solve it like a quadratic. In fact, we're going to start by rewriting that equation as a quadratic. So we're going to rewrite the equation as a quadratic by replacing, substituting, whatever word you like there, the first variable with a squared and the second variable with a. So what we want to do is rewrite our quadratic-like equation as an actual quadratic. So whatever weird variables we have here, if our weird variables were a to the fourth and a squared, or sorry, x to the fourth and x squared, then we're just going to replace that first one with a squared, and then we're going to replace the second one with a. Where I'm not going to change my coefficients, I'm not going to change my constant, I'm just going to rewrite those variables so that it looks like a quadratic equation, so that it looks like the one we know how to solve, okay? Now I'm using different variables on purpose because when I solve for the variables that I've put in there, I want to make sure that I'm not stopping because I'm not actually solving for the x that my equation started with, okay? So I'm going to replace the variables with a squared and a every single time. Whatever the variables are, the first one's going to get replaced with a, and or a squared, the second one's going to get replaced with a. And again, our coefficients and constants are not going to change. And the new equation that we've written with these new variables is a quadratic, and that we're going to be able to solve by factoring. Now I know there are other ways to solve quadratics, just for the purposes of where we need to go with this, we are going to focus on quadratics that are factorable, okay? So we're going to solve the new quadratic equation by factoring, but that's going to get us solutions for the variable that we substituted in there. That's going to give us solutions for a, and technically we want to solve for x because that's what was in our original equation. So once we've solved for a, we're going to replace a with the original middle variable because that is what a replaced in the beginning, okay? So let me show you how this works. Let's look at this particular equation here. So first, it is a quadratic-like equation. We have 3 terms equal to 0. The third term is a constant. The first exponent is twice the one in the middle. So the first thing I'm going to do is I'm going to replace the variables so that this thing looks like a quadratic. So the first variable and the second variable are going to get replaced every single time. I'm going to replace this one with a squared and this one with a every single time. Not going to change my coefficient of 1, my coefficient of negative 17, or my constant of 16. So when I rewrite this, that looks ugly, I'm going to make this 1a squared minus 17a plus 16 equal to 0. Because this new quadratic equation is something that I know how to solve. The factors of 16 that make negative 17 are going to be negative 16 and negative 1. And so the first factor here tells me that 16 is one of my solutions for a, and the second one tells me that 1 is one of my solutions for a. So I've solved for a. Now be careful, again, we are trying to solve an equation that has x in it, right? Not a. So we're going to have to do some more substitution. So we substituted in a variable so that we can factor in and look at this thing as a normal quadratic. But now that we've solved for a, we got to get rid of a. We got to go back to the x's that we were trying to solve for. So I'm going to replace a with what a replaced. So in the first term here, a squared is what replaced x to the fourth, but I'm not concerned with that. What I'm concerned with is what a replaced, because I solved for a here. So what did a replace? What did we substitute in a for? We substituted a in for x squared. So a represented x squared. So if a represented x squared or was substituted in for x squared, then, or if a replaced x squared, then now I'm going to substitute x squared back in. I'm going to replace a with what a replaced. So again, a replaced x squared. So now instead of a equals 16, I'm going to replace a with x squared equals 16. And the same thing here, x squared equals 1. And now we can solve for x. And we know how to solve for x. We know how to get rid of the square. We take the square root of both sides. So here, x is going to be equal to plus or minus 4. And then here, we're going to take the square root of both sides, and we end up with x equal to plus or minus 1. And 4 solutions we end up with for this equation. And 4 possible solutions make sense because we started with a 4th degree equation. Okay, and there they are. And if you wanted to check those solutions, you can plug them back in, and all 4 of them are going to work. Okay? What do you think? Good stuff, right? Substitution. All right, let's try this again. I know these variables look a little strange, but this is still a quadratic-like equation. So I'm not going to change my coefficient, or constant. Okay, I'm just going to replace the variables because they're what makes this thing look weird. So I'm going to replace x with a squared and x to the 1/2 with a. Every single time. First variable gets replaced with a squared, second one with a. Unless you like another variable, I just like a. If you want to use b or c or whatever, it doesn't matter. We're just substituting in a different variable. Okay? So I'm going to make this 1a squared plus 3a minus 40 equals 0. Again, didn't change my coefficients or my constants. But now I can solve this by factoring. Factors of negative 40 that make 3 are going to be a positive 8 and a negative 5, which means negative 8 is a solution for a, and positive 5 is a solution for a. So now that I've solved for a, I'm going to get rid of a. Okay, I need solutions for x. So I'm going to replace a with what a replaced. And a replaced x to the 1/2. So now I can replace a with what it replaced, which is x to the 1/2. So instead of a equals negative 8, x to the 1/2 equals negative 8. And again, x to the 1/2 is going to equal 5. Now how do we solve for x from here? If you recall, x to the 1/2 is the same thing as the square root of x to the first. So if you want to look at it as a square root, maybe that's easier for you. But to get rid of a square root, what do? We square both sides. So if I square both sides here, I get x equal to negative 8. Gosh darn. Thought I switched, but I didn't. X is going to be equal to 64. And then over here, if I square both sides, x is going to be equal to 25. Now, let's go back to our original equation real quick. The degree of our original equation is 1, which means we should only have one solution to this equation, not two. And maybe you recognize it sooner than I'm pointing it out here, but one of these solutions is extraneous. Can you see which one? Well, the 64, if I put 64 back in here, the square root of 64 is not going to give you a negative 8. And so this 64 is extraneous. Remember, we cannot take the square root of something and get a negative. That's just not going to happen. So this solution is extraneous. We can, just to clarify, we can square root negatives, but I can't square root something and get a negative. So again, I could square root a negative 1 and say that it's I, but I can't square root a number and make it a negative. Okay, that can't happen. So make sure you're not confusing those items. So that solution was extraneous, which is good because we really should have only had one valid solution, and that's going to be 25 in this case. Okay? Hopefully this isn't so bad. Some of them definitely look a little worse, like maybe number 3 looks a little intimidating here. But you might be tempted to like multiply this stuff out. Don't do that. This is a quadratic-like equation. We've got one term here, second term here, third term here. Third term's a constant, and the first exponent is twice the second one here. So 2 is twice the one that we have in the middle. So what we're going to do is rewrite this as a quadratic. I'm going to replace the first variable piece, which is this whole thing in parentheses. That's going to get replaced with a squared, and then this whole thing again is going to get replaced with a. So I'm not going to change my coefficient of 1, my coefficient of negative 12, or my constant of 20. So when I rewrite this, I'm looking at a squared, 1a squared, minus 12a plus 20 equal to 0. That looks a lot more manageable. So factors of 20 that make negative 12 are going to be negative 10 and negative 2, which means a is going to equal 10 and a is going to equal 2. So those are solutions for a, but remember I want solutions for x. So I'm going to replace a with what a replaced. So a replaced x squared minus 2. So now I'm going to put in x squared minus 2 for a. So instead of a equals 10, x squared minus 2 equals 10, and the same thing here, x squared minus 2 equals 2. And now we can continue to solve for x. So we're going to add the 2. That's going to give us x squared equals 12. and then we're going to take the square root of both sides. So x is going to equal plus or minus. Radical 12 is going to simplify. Since 2 goes in 6 times, and then that's 2 times 3, a 2 can come out, and a 3 will stay in. So plus or minus 2 radical 3. And then over here, we're going to add 2, and it makes a nice perfect square for us. So we have x squared equal to 4, and then when we go to square root that, we get x equal to plus or minus 2. So we've got 4 solutions on this one, which should make sense. If you look at the original equation, we have an x squared squared, which is x to the 4th altogether. So again, that should make sense. Okay? All right, I gave you one to try. I gave you one with fractions to try. If you're feeling pretty confident, then give it a shot. If you're a little intimidated by the fractions, please don't be. This is exactly the same as the last 3. The variables are the weird thing, so let's get rid of those. Let's replace the first variable with a squared and the second one with a. So 1a squared minus 2a minus 8. That way we have a quadratic that we can manage. And factors of negative 8 to make negative 2 would be negative 4 and positive 2. And so a is going to equal 4, and a is going to equal negative 2. Now we got to replace a. And we're going to replace a with what it replaced, which was x to the 1/3. So instead of a equals 1/4, this is x to the 1/3. Instead of a equals 4, it's x to the 1/3 equals 4, and x to the 1/3 equals negative 2. And just like the square root was the 1/2 power, the 1/3 power is going to be a cube root. So if you want to look at this as a cube root of x equal to 4 and a cube root of x equal to negative 2, then all we have to do to solve is cube both sides. And we don't have restrictions with the cube root, so don't worry about that negative. So we're going to cube both sides and cube both sides here. So this is going to leave us with x equal to 4 cubed, which is 64. And this is going to be x equal to negative 2 cubed, which is going to make a negative 8. Both of these are going to be valid solutions. Okay. Now this is a little harder to see. The number of solutions here, that 2/3 power, is a little tricky. But remember, the 2/3 power is a cube root of x squared, and since we have a quadratic in there, we can end up with those 2 solutions. Okay, so I know that's a little tricky, but those 2 solutions are both going to work. All right, moving right along, just trying to give you some more examples so that you have plenty of stuff to reference. Here we finally have a leading coefficient that isn't 1, but again, our same process will work. So let's replace the first variable with a squared and the second one with a. So we're going to make this 9a squared minus 38a plus 8 equal to 0. So we got to go through the whole bottoms up process here. We're going to look for factors of 72 that make 38, like 2 and 36 if they're both negative, and they have to be divided by 9, and that's going to reduce. So this is going to factor into 9a minus 2 and 1a minus 4, and then we have a equal to 2/9, and then we have a equal to 4. Okay, so we've got solutions for a. Now we got to get rid of a. We're going to replace a with what a replaced, which is x squared. So now this becomes x squared equals 2/9, and x squared equals 4, and again we can square root to solve. So square root, everything here. That's going to give us x equal to plus or minus the square root of 2/9. Well, I can't square root. Remember the square root property, right? We can separate this into square root of 2 and square root of 9 separately, which would be good because we can actually square root the 3 and not have to deal with something that's irrational there. So it's going to be a radical 2 over 3, and then here's a nice easy plus or minus 2. So 4 solutions, again, makes sense for the equation that we started with. And just make sure that if your leading coefficient isn't a 1, that you're using that entire bottoms up process. Okay? All right, I think this is probably the one that I see the most mistakes happen on. I'm not entirely sure why, but let's try this one out so we can make sure we're prepared. We're going to replace our first variable with a squared, second one with a. So it's going to be 1a squared plus 3a plus 2 equal to 0. Factors of 2 that make 3 are 2 and 1, which means our solutions for a are going to be -2 and -1. And now when we go to replace a with what it replaced, we get something that's a little weird. We get this x to the -1 equals -2, and x to the -1 equals -1. So there's a couple ways, and I'll show you with the two different equations that we have to solve here. There's two ways you can look at this. The goal is to get x to the positive first, right? So what I could do is raise both sides to the negative first. If I raise both sides to the negative first, then I can multiply these and say x to the first is the result. Okay, and that's the goal. But then on the other side, I have to figure out what -2 to the negative first is, which I know, but technically if you weren't sure about that, that is something that you could put into the calculator. Sorry, because there are no variables involved there. So if you put in -2 and you raise it to the negative first, you get a -1/2. Now why is that? Why do we get a negative half here, or -0.5? Because our negative exponent rule. If we have something with a negative exponent, it belongs on the other side of the fraction. So instead of this being -2 to the negative first over a +1, is supposed to be, oh my gosh, clicked the wrong thing. It's supposed to be 1 over -2 to the positive first. So anything with the negative exponent is supposed to be on the other side of the fraction, and once you move it to the other side of the fraction, you can make that exponent positive. And so that's why we end up with a -1/2 here. So -1/2, but again, that was something that you could have just put into the calculator. So we end up with x equal -0.5 or 1/2, either way. So one option is to just raise both sides to the negative first, because the goal was to get the power of 1 x to the first all alone, right? Or you can use that negative exponent rule right out of the gate. So x to the -1, that is the same as 1 over x to the +1. And on this side, -1 could be written as a fraction. And then if we wanted to we make this a proportion. If we wanted to cross multiply, then we could say -1 times x would be a -x, and we could also say that 1 times 1 is 1, and that those two fractions would have to be equal. So if -x equals 1, then x is going to equal a -1. Okay, so you have the option, kind of use whatever you're comfortable with or whatever makes a little more sense to you, but we have x equal to -1/2 and x equal to -1 as our two solutions. And again, it might be a little hard to see that there should be two solutions here, but again, think about what this is. X to the -2 is 1 over an x squared. So there's a quadratic in this equation, okay? Alright, so ugly as it is, there it is. Let's try another. We're almost there. Let's see, we're going to replace this one with a squared, this variable with a, so 1a squared minus 5a plus 4 equal to 0. This is factorable. Factors of +4 that make 5, -5 are going to be -4 and -1. And so a is going to equal 4 from that first factor, and a is going to equal 1 from the second. So we have now to replace a with what a replaced, and it replaced x to the 2/3. So we have x to the 2/3 power equal to 4, and x to the 2/3 power equal to 1. And so remember, this is a cube root of x squared equal to 4, and a cube root of x squared equal to 1. And so the first thing we want to do is get rid of the cube root by cubing both sides, and that's going to give us x squared equal to 64. And then we can take the square root to get rid of that square, and so we're left with x equal to plus or minus 8. And then this next guy, same thing. Let's cube both sides. So we end up with x squared equal to 1. And now we can square root both sides, and we get x equal to plus or minus 1. So we've got 4 solutions to this equation. Again, a little hard to see, but if we go back to our original equation, this is a cube root of x to the 4th. So we've got a degree of 4 in there. That's 4 possible solutions. Okay? Just so that doesn't confuse you later. I don't want confusing stuff left in there later. If you're watching the video, it won't be confusing, but if you're not, you're going to be like, what the heck? Okay, so one last one. If you're feeling good, again, just give this a try. There's 6 possible solutions we could be looking for here. Doesn't mean we get 6 every time. Remember, there's the possibility of getting extraneous solutions sometimes, or just, invalid solutions. So we're looking for possible 6 possibility of 6 solutions. And also, sometimes we have solutions that repeat, right? Like a quadratic can have 2 solutions, but it's the same solution twice, so we only see one. So that kind of thing can happen. But 6 possibilities here. So we're going to replace this and this. And so we've got 1a squared plus 9a plus 8. And factors of 8 that make 9 are going to be 8. Do you guys do this too? Okay, sometimes I write 2's like this, and sometimes like this. And sometimes I write 8 like this, and sometimes like that. I'm not sure why, or what's happening in my brain, but I hope I'm not the only one. Alright, so a plus 8 and a plus 1. And that means that negative 8 is a solution for a, and that negative 1 is a solution for a. So now we're going to replace a with what a replaced. So a replaced x cubed, and so we have x cubed equal to negative 8, and x cubed equal to negative 1. And so to solve, we're just going to take the cube root. Take the cube root of negative 8, and we're going to take the cube root of negative 1. And so x is going to equal a negative 2, and x is going to equal a negative 1. And so 2 solutions, again, 6 were possible. We only ended up with 2. It just means that some of these solutions are repeating. Actually, later when we get to our polynomial unit, we're going to talk about the behavior of the functions that correspond with these equations and why these repeats happen and what that looks like. So we're going to get more into that later, but these are our 2 valid solutions for now. Okay, so those are quadratic-like equations. As always, you've got some problems to practice, so get going on those, and if you need some extra help, then just reach out. All right, guys, take care.